What's going on, y'all? It's the Cool Teacher here to show you how to find the greatest common factor of two or more numbers. Now, I know I've showed you how to do this in the past, but this is a new method, and it uses what we call the upside down wedding cake method. I know it sounds crazy, but trust me, you'll see why it's called that in a second. Now, I feel like this is the easiest way to find the greatest common factor because we use something called prime numbers. Now, I have the first 10 prime numbers listed here, and a prime number is a number that's only divisible by 1 and itself. So take 2 for example. I can divide 2 by 1 and 2. Take 3 for example. I can divide 3 by 1 and 3. But you can see 4 is not up there, and that's because 4 is not a prime number because I can divide 4 by 1, I can divide it by 4, but I can also divide it by 2. Remember, it only has to be divisible by 1 and itself. Quick crash course on prime numbers. So let's go ahead and find the GCF of these two problems. Now, like I said, I'm going to use the prime numbers here, and what I'm going to do is take both of these numbers and divide them by one of these 10 prime numbers that you see down here. Now, I have to make sure that I'm using a prime number that goes into both of these. And since both of these numbers are even, guess what prime number goes into them? Yep, 2. So I'm going to go ahead and divide both of these by 2. Now, I know you're probably looking like, wait, if he's dividing, why is the house on the bottom? Remember, this is a upside down wedding cake, and like I said, you'll see why in a second. Now, when I take 24 and divide it by 2, I'm going to get 12. And when I take 48 and divide that by 2, it's going to give me 24. And what I'm going to do now is just to repeat that process over and over. Look at these two numbers. Look for a prime number that goes into both of them, and then divide it by that prime number. Well, they're still even numbers, so I'm going to divide it by 2 again. $12 divided by 2, 6. 24 divided by 2, 12. And I'm going to divide these as well, because obviously you can see the pattern. They're both even. I'm going to divide them by 2. Now, every single problem that you get won't be everything being divided by 2. That's why you have those prime numbers listed here at the bottom, so you know what numbers to try to divide it by. 6 divided by 2, 3. 12 divided by 2, 6. Now I have to go ahead and divide these. Now, these are not even numbers, but what is a prime number that goes into both 3 and 6? Looking at my list down here, I know 3 can go into both of those. So I'm going to divide both of them by 3. 3 divided by 3, 1. 6 divided by 3, 2. Now, this doesn't always happen, but when you get to a 1, that means you're done and there's nothing else you can divide by, because the only thing that can go into a 1 is a 1. Now, this doesn't always happen, but when it does, you know that you're finished with the problem. Also, you can go ahead and see why this is called the upside down wedding cake method. If I took a wedding cake and flipped it upside down, kind of resembles what I just did. So I'm done with the first part of the problem. The second part of the problem is to go ahead and take all these numbers that are on the outside, and I have to multiply them by each other. So
2 times 2 times 2 times 3.
Well, 2 times 2 is 4. 4 times 2 is 8. And 8 times 3, that's going to give me a 24. So my GCF for 24 and 48 is going to equal 24. Now, it doesn't matter if there's 2 numbers that you're finding the GCF for, 3 numbers, 4 numbers, 10 numbers. This method works for however many numbers you have. Now, in this case, you have 3 numbers here. We're going to find the GCF using that same method. Going to divide this by what? 2, because they're all even numbers. Just make it easy for yourself. 12 divided by 2, 6. 16 divided by 2, 8. 20 divided by 2, 10. Now, before I continue this problem, sometimes a lot of students will see 12, 16, and 20, and they'll be like, oh, I can go ahead and divide it by 4. Now, while 12, 16, and 20 all can be divided by 4, 4 is not a prime number. So if you were to do that, you'll mess up the whole problem and you won't get the right answer. So remember, always divide by prime numbers. Once again, looking here, I have 6, 8, and 10, all even numbers. So the prime number I'm going to divide these by is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 10 divided by 2 is 5. Now, is there a number that goes into 3, 4, and 5 that's a prime number? Well, I know 2 can go into 4, but it can't go into 3 or 5. 3 can go into 3, but it can't go into 4 or 5. And 5 can go into 5, but it's too big to go into 4 or 3. So you know what that means? We are done. And if you're ever unsure, literally you can take any of these numbers and divide them by any of these prime numbers down here to see if it works. If you get a remainder, if you're working it out by hand, it's not going to work. If you get a decimal, if you're working this out by calculator, it's not going to work. So there's nothing else for me to go ahead and divide by here. So my second step, multiply those two together.
So I have 2 times 2.
And this one is pretty easy, 4. So my GCF of 12, 16, and 20 is going to be 4. And that's how you find the greatest common factor of 2 or more numbers using the upside down wedding cake method. If this helped you, send it to somebody else so you can help them. Other than that, this is the Cool Teacher, and I'm out.